I have worn many hats in my IT career, but for purposes of this talk, I'm going to call myself a developer who likes to write tests. So I was trying to think of a good way to start off this talk late last night, and I figured that it would be good to start with a story. The problem is, I'm a really terrible storyteller. I always get the order wrong and leave out important details. But I know a good story when I see one. And so I thought it would be maybe worth trying remixing a story that I know is really good into something that's kind of relevant to this, this conference. So let's go ahead and start. A long time ago, in an investment bank far, far away, we had a developer. He was an experienced developer, and he loved to write tests. And he joined a new team working on an instant legacy web application. I'm not sure if you've heard much about instant legacy web applications, but basically by the time you deploy them, they already are an enormous pain to work on. Anyway, this team was ruled by an empire of big, scary tests. And this developer had dreams of defeating that empire by eliminating duplication and accidental complexity and bringing about readability, clarity of intent, and maintainability. But the code base was large, and the technical debt was even larger. And so those dreams seemed forever out of reach. Then one day, a colleague introduced the developer to Eric Evans' book, Domain-Driven Design. That book espouses techniques like developing a ubiquitous language between the business and the technical sides of the team, and ensuring that the model and the implementation are deeply connected. This was a revelation to our developer. It was as if he'd taken his first step into a larger world. And now our developer felt there was some kind of force guiding him to restructure the test code. Fortunately, his teammates felt it too, and so armed with this new weapon, they attacked the enemy with epic resolve and determination. I'm not sure if you can read this, if anyone can read this, no matter where you're seated, but it's really terrible code, test code specifically. They emerged victorious by completely destroying the previous structure in the test suite, or lack thereof. And that led to massively improved readability and true maintainability. I mean, real maintainability. It actually became more fun to work on the test than it did on the application. Think about that one for a while. So, what's the moral? Now, I don't think it's about the developer. I don't think it's about the author or the book. And it's kind of, sort of about the team. And I think the point is, it's about having a philosophy towards software development, and by extension, test automation. And that is continuous improvement. We're always striving for a better way to do things. Even on this team, things that may not be within the remit of a traditional development team. So, it's great to talk about philosophy and stories, but I'm guessing that there's some folks in here who might be interested in the details of how we did this and how I've been structuring my test code since that gig. I'm not sure if you can tell what this is. This is apparently a schematic diagram of a real lightsaber. So that's, if you want to build one, that's what you got to do. So what I'm going to give you is the story behind the story here. So I've got a collection of practices that have worked for me on my projects. I'd encourage you to try them if they apply to your situation. And if they don't, I'd strongly encourage you to try to come up with your own. And I'm not going to call these best practices. If you're interested in knowing why, there is a link to a talk that Dan North gave a few years ago at the end of this deck, which you'll get copies of later. So, why page objects? Why do we use them? Basically 3 words. Maintenance, maintenance, maintenance. we need to make sure that our test code is, that we're giving it the TLC that it needs in order to continue to deliver value. As we add more functionality to our app, we need to make sure that we can write tests easily and maintain them without false negatives or wasting a lot of time with trying to puzzle through unreadable code. So what does good code look like? We've actually, Adam and Patrick have been talking about a lot of the properties of good code, specifically in the page objects talk yesterday. So I'm not going to spend a lot of time on this, but here's a sort of non-definitive list of properties that you want to see in your code, whether it's test code or your app. Readability. Basically, when you glance at it, you should be able to tell what it does. That helps non-technical users. It helps new team members. It helps existing team members who didn't happen to be sitting next to you when you wrote the stuff. Just helps with comprehensibility. Staying dry. I think we all know what dry is. It's not just for developers. It's important for toddlers too. I'm pretty sure this is a word. Basically, what it means, in case you're not familiar with it, is non-brittleness. No false negative failures. We don't want to waste time fixing breakages that aren't due to actual changes in the app code, be they intentional or not. Sensible names. It should be pretty obvious from a class's name what its responsibilities are, and it should be pretty obvious from a method's name what it's doing. Small classes. Boy, whew. This is actually not the worst I've ever seen, by a long shot, I'm sad to say. But it's really hard to keep all that stuff in your head and to try and traverse up and down enormous code file. You're going to wear out the scroll wheel on your mouse. You just want small classes to make it easier to deal with your code base. So how do we get there? Well, we apply techniques like refactoring. We use design patterns. Basically, we do continuous improvement to our code base. Now, next slide, I kind of struggled whether or not to include this because I don't like to be the guy who beats the drum for a particular tool. But I've noticed a couple of things in the past few gigs. A lot of folks are still using vanilla text editors for writing code. And I'm not talking about power Vim users who have all the plugins and keystrokes mastered. I'm just talking about TextPad. And a lot of folks are using refactoring IDEs like IntelliJ and Eclipse, but they aren't taking advantage of their power. And I think this is a real shame because these tools can save you a lot of time. Particularly if you're using a strongly typed language like C# or Java, that automated refactoring support just can be a real lifesaver. And it makes, in my opinion, coding a lot more fun. So anyway, check those out. Right, so context for some of these tips that I'm going to serve up in a bit. I've been doing consulting gigs over the past few years. My current client has a pretty big consumer-facing rich internet application. I guess it's a rich internet application. We've been writing tests with the Selenium 1 API in Java. Now, here's a quick free tip. If you can, use WebDriver. Yeah. Because, as I've found, it actually supports a lot of the stuff that I've had to kind of code around in Selenium 1 by default. So you can skip a lot of additional code. You get a nice, really clean API. It's just a really nice thing to do for yourself if you can. So let's do a quick recap of page objects, what they do. Basically, we're using them to model the application's user interface. And they expose methods that correspond with the things that a user can do or see on that page. And they hide the details of telling the browser how to do those things. So basically, we're going to keep all of the Selenium API calls inside of our page objects. Again, Patrick and Adam have covered this stuff. Benefits: readability, reduce eliminated duplication, self-verification. Basically, when you instantiate one of these things, it can automatically tell whether or not the corresponding user interface element is on the page and fail the test immediately if not. And reusability of our test code. So, so why go beyond page objects? So web apps are a little bit different now. So how are they different? I mean, because they're different because they have rounded buttons. Well, maybe. Reflective logos? Yeah, no. No, it's because modern web applications are dynamic and rich. So you can't rely on a page load signaling that the UI is ready. It's just that the DOM is going to be updated in response to user actions that may or may not correspond to a page load. Additionally, these interfaces are really rich. It's difficult to model them as a suite or sort of a set of monolithic pages. I mean, we're not just in this world where we have a static template with a hole in the middle for content. That's just not the way applications look anymore. They look a lot more like desktop applications. Has anybody here not heard of Pivotal Tracker? Okay. Pivotal Tracker is a really fantastic piece of software made by the folks at Pivotal Labs. It is issue tracking software as a service. It's designed to support an agile way of working, and it is highly, highly dynamic. So it's collaborative software, and when you're using it and your teammates are using it, you'll actually see the updates that your teammates make to other issues on screen in near real time. So this is a crazy hotness, to be honest. And I dare you to model this as a single page object. I mean, you would go nuts. So yeah, we're going to have to adapt the page object pattern a little bit in order to make this app testable, or in order to use it to test this app, rather. So I apologize a bit for this next slide. I was going to do sort of a little live demo of Pivotal, but I kind of chickened out a little bit because of network stuff. But anyway, let's do a quick little intro. On the left, we have a list of issues corresponding to the tasks that the development team is likely to do in the current iteration. And we see that we have this, we can sort of expand each item in there to get a edit sort of interface there, where we can make changes to the state of the issue. So here we're going to actually add a comment to this issue. We're going to click that button, and we're going to see that that comment is now saved into that issue. And we can then save the state, and that collapses that that issue back down to that sort of summary state. So so there's a couple interesting things here which we may want to actually model in our test code. So when you are using Pivotal, you can't edit an issue unless it's in that expanded state. So, so from the standpoint of but rather, I'm getting ahead of myself. Let's take a look at the code. How are we going to model this, this user interface? Well, we're going to break it up into pieces. So we're going to create a couple of classes corresponding to those compressed and expanded views of the issue. So I'm going to call the first one Issue Summary. And it should have methods on it like expand, get title, get labels. I don't know if you saw on the left there were some labels on those issues. And for that expanded edit view, we have an issue detail class. And that has methods on it that correspond to all the things that you can do when the issue is in that expanded state. Now, if you take a look at this code, I'm not sure I can actually use the pointer over there. But you'll see that the return value of the expand method is the issue detail type. So basically what that is sort of telling us is that you won't have the ability to do a save or cancel or get story ID until your test clicks expand. And so that's kind of a neat little way of modeling the user experience that, that's actually in the application's behavior. So we have sort of this, again, this, to go back to the domain-driven design book, sort of this deepening connection between the model and the implementation. So, so what are these things, these little mini page objects? It seems like we struggled to come up with a good name for them yesterday. I've been using the phrase page components, just to make it clear that there's a compositional relationship between these little pieces and the page as a whole. Is this just semantics? Maybe. I personally think that names are important because they can very quickly convey a lot of sort of deep information about a topic. They basically have, the same, again, the same properties as page objects. It's just that they're modeling a piece of the UI rather than everything in the window. So we can use, because they're basically the same as page objects, you can use some of the same little tricks that we have that we can use with page objects. So we could use, for instance, method chaining. If we have a user action on our page component that, what we want to do is we want to model the way the user's focus moves from one component to another by varying the return type of the action methods on the page component. So what does that mean? When you add a comment to an issue in Pivotal Tracker, the expanded view stays open. So you can continue to do other actions on that detail view. So for instance, the save action is also on the issue detail view. So we can write test code like issue detail, add comment, save. Now, this is kind of nice because it sort of allows us to string together multiple statements at once. But the really cool thing is, as we'll see later, if you are using one of those modern IDEs, you can use control space to tear through that stuff in a fraction of the keystrokes you would normally use if you had to type it out manually. It's a really, again, fun way to write code. Again, method chaining, what happens if the focus moves to a different page component? Well, we just change the return type. The delete method on, we didn't actually try to delete an issue, but what happens in Tracker when you try to delete an issue is it pops up a little confirmation message and says, are you sure you want to do this? Confirm or cancel. And so when our tests invoke the delete method on an issue, we're going to make the call to click the button, and then we're going to return a new confirmation dialog so that our test can then immediately call either confirm or cancel. So if the caveat here is if the focus destination is kind of ambiguous, I don't really worry about it too much. I just make the return type void and allow the test author to just sort of pick up from a different place. Because I don't want to sort of create unpleasant surprises for users of my page components. So to wrap up on page components, they're just like page objects, but littler. And we can still use return types to model the user experience. And when we broke issue summary and issue detail out into separate classes, out of our hypothetical enormous monolithic page class, we basically reduced the size of that hypothetical page class, and we ended up with some nice, concise little classes for the issue summary and issue detail. And we ended up with a way to model the actual user experience that that the user has when they deal with one of these issues. Okay. So next, here's another sort of technique that I used, and that's called I call this the component factory. Now, does anyone, who here likes to type? Who really kind of digs typing? It's okay, it's okay. Okay, no one's willing to admit it. I don't like typing. In fact, I would even say that my job satisfaction is inversely proportional to the number of keystrokes required to write useful code. God, that sounded even geekier than it did when I wrote it. Whew. So this may be a reaction to this old refrain about pair programming that you'll have a team that's half as productive because there's only one keyboard and two sets of hands, as if the value of computer programming, basically computer programming, came down to typing. And God, that's ridiculous. Anyway, component factory. What does it do? Basically, it is a repository of sorts for new instances of my page components. And repository is actually not a good word. It's a way to access new instances of these page components, hence the factory name. So we'll have a method on the component factory for every page component that the user can sort of, or that the test should be able to sort of access ambiently. If you remember in the Tracker application, we had the leftmost column, which was the current iterations worth of stories, and then we had another column that had the backlog, so basically all the upcoming stories. We would have methods on the component factory corresponding to each of those two page components. So, interactive documentation, I think that's the big win for the component factory. We do get an easier entry point into accessing those page components rather than having to instantiate them directly. We have another way to use strong typing to make the tests easier to write. So some of you may be using a dynamically typed language like Ruby or Python. And I only have two words for you with regard to sort of this technique. You can't use it, sorry. I do like Ruby and Python, I'm not a hater. But it turns out that strong typing is actually good for some stuff. This is perhaps one of the best things about it. One other thing that's worth pointing out, because this has a very similar name to the WebDriver Page Factory, I think it's worth pointing out that they are completely different beasts. The WebDriver Page Factory is more around sort of reducing the complexity inside your page objects or page components, whereas this component factory is more about making it easier to access new instances of them. So they're kind of solving different problems. So yeah, component factory, it's a little bit of syntactic sugar, priming the pump for a modern IDE, making it easier to do your job. Yeah, for those of you who really hate to type, it's worth checking out. Okay, next, let's take a look at indexed components. So this is another set of, or another sort of pattern that I've used to help organize the tests and the code inside my components. If we take a look at the tracker UI again, you see we've got a list of issues here. And you basically, in order to really test this app, you're going to be able to access these arbitrarily at will, so that you can call the different methods like getTitle, expand, et cetera, et cetera. We're going to want to be able to do something like this. With component backlog, issue summary 0, that should give us the first issue summary instance, and we should be able to say, assert that the title is some string. If we imagine for a minute that the structure of the DOM for Pivotal Tracker is really simple, I have no idea what it looks like, but if we imagine that it's really simple and kind of designed for testability, this is kind of how I would expect it to look. You would have a container element for the backlog, and that might have an ID of backlog. You would have a class on each of your issue summary elements called issue summary, and you would use the nth locator to get access to each of those issue summaries. And then for each of the little user elements on the buttons and the elements on the issue summary, you'd probably have another class on there, like .expand for the expand button, or .title for the title. So that looks pretty good, but there is quite a bit of duplication there. And when I'm going to be putting together my locators for my page components, it's going to be a little bit tough because of the indexing. So I can't just extract a constant to say, okay, well, I'm going to have the root locator be issue summary nth 0, because what happens when I want the second one, the fifth one? So we could, create a method, I guess, to create that root locator for us. But you kind of still end up doing a bunch of string concatenation, and string concatenation is kind of ugly sometimes. So I ended up creating a locator class. And so what does a locator do? It basically holds a piece of a CSS expression for us that corresponds to sort of the root of a page component. We pass in the index so that we know which item in the list of items we're talking about. And it has a little method on it that allows us to pass in the class of the contained item, and which will return the fully qualified CSS expression. So let's see how the code looks for this. So in our original version of the expand method, we'd have selenium.click, blah-de-blah-de-blah-de-blah-de-blah, expand. Or we could have click, locator.of, expand. So again, this is just kind of a nice readability improvement. It also eliminates a little bit of duplication in those in terms of those CSS expressions. Yeah, you don't have to concatenate strings. All right, we're getting close to the end here, and I want to cover the last bit, which is synchronization issues. Now, again, this is a big issue that comes up when we're testing these really dynamic web applications. And the problems pretty much come down to two main problems. Your element isn't present yet, and you try to interact with it anyway. And maybe your element is already there, but the content hasn't been updated yet. So what mechanisms can we use to kind of solve these problems? Oh, I know, thread.sleep. No. I think we've covered that. That horse is dead. Unless you have no other choice, which sometimes you don't. If you have no other choice, just be sure to wrap it in a method that's named appropriately. We've been using sleep as a last resort when nothing else works. Yeah, okay, I mean, you see the method, you think about it. If you practice mortgage-driven development, you might like this one. Yeah, okay. And then if you are just really lazy, basically, okay, seriously, thread.sleep should be a solution of last resort. Treat it as such. And yeah, you can use this pattern to discourage people from doing things that they shouldn't. So how do we really want to solve this? We want to use the wait class. So we want to delay the test until the app exhibits certain behavior rather than waiting for an arbitrary amount of time. We want to, for instance, always wait for an element to be present before we try to click on it, maybe, just to make sure it's actually present in the DOM. So we kind of have two options for doing that. We could subclass default Selenium and override the click method. Or we could extract a base component class that provides a click method for use by all of its subclasses. It's a bit of a matter of taste. Personally, I prefer the second approach because then when I'm in the debugger running through a test, I can call methods on the Selenium object directly and not have to wait for the method to time out in case I try to access something that doesn't actually exist in the DOM yet. Those of you who are actually using WebDriver already may recognize that this is sort of an implicit wait strategy, and it's already been in the WebDriver for about a year now. So yeah, here's a point where you might want to use WebDriver instead. So the next issue is that the element is present in the DOM, but it doesn't contain the right data yet. This is tricky. So the best way to solve this, this issue is actually to build the app for testability. So Adam Goucher actually wrote a cool article on the Sauce Labs blog about how you can use JavaScript in the app to set a flag to let the tests know when the app is ready to be interacted with. There's a link to that at the end of the slide deck. That would be sweet because it's a nice consistent way of dealing with this problem. The next best solution, if you don't have the ability or the time to change the app, is to pretty much do what the user does. That is, you take a look at the state of the app before you perform your action, you do the action, and then you check to see whether the app state has changed. So for instance, with our add comment behavior on the tracker UI, each issue detail has a comment count on it. We can check to see what the comment count is. We can enter our comment, and then we can wait until the comment count is whatever it was to begin with plus 1. So this is definitely a lot more sort of specialized and labor-intensive than the previous solution, but it sure beats having flaky tests. So that's what I've got for specific improvements to page objects and little tips and techniques for dealing with dynamic web apps. But I wanted to say, when I first sort of conceived this talk, I was really focusing on those improvements, and specifically on how you could use those to improve your test code. But as I started thinking about the journey that I've kind of taken to get here, I kind of realized that the specific techniques, while useful for now, are kind of not the point. The point is that you really need to keep your eyes and your mind open, and to be brave and not afraid to try new things when you start to reach the limits of your existing tools and techniques. And so with that, I say thank you. Right. OK, so the question is, what is the overhead of maintaining the suite of page components, particularly when there's being new functionality added to the app? Is that a pretty good summary? So I would argue that it's certainly no more than effort than you would spend if you weren't using page components. And certainly, it should be quite a bit less, because you should have less duplication in your test suite than you would otherwise have. I realize that it might seem a bit daunting if you're not used to dealing with code in this way, but I think there's actually a lot of room for sort of cross-functionality between developers and testers. I think this throw-it-over-the-wall mentality that has kind of persisted through this industry forever that's a bygone era, and so we need better collaboration, I think, on all fronts.
So are you saying that developers should maintain the data?
Well, I'm a developer and I maintain my tests, so I think it's not a bad idea. So the question is, where do I like to put my locators, in a properties file or in the code, in the class file itself? I prefer to put them right in the code, because then I don't have to navigate to a different file to find out what this particular locator or locator key is. It's just right there in the class. We should already only have one place for the locator anyway, now that we're using page objects, or page components. So yeah, we've eliminated the duplication problem, and I think there's no need to kind of put them in a properties file. Okay. All right. Okay. Thanks again.